Hello everybody, I'm Alexy Khrabrov, the organizer of SF Scala, and here with us we have a very special guest, John Pretty, who is one of the most experienced Scala veterans. He uses Scala since 2004, and in Paul Phillips's famous quote, it took him 10 years to gain 10 years knowledge of Scala, which is most impressive. And a
Paul did add that it took him, I think, about 2 years to get the same amount of experience.
Right. We're going to ask him next time when Paul is here. We're going to put that to the test.
I'll look forward to that.
But that's great to have you with us. We have John Pretty is talking today about Rapture, and we're going to do a workshop and follow along. But first I will welcome you here.
Thank you.
It's great to have you with us here at Nitro.
Thank you for the kind introduction.
And obviously it's not very often we meet somebody who did so much Scala and from so early. So maybe you can tell us, how did you discover Scala? What interested you in it, and what kept you in it for all this time?
So I discovered it back in summer 2004, and I was setting up a business with a friend of mine. We wanted to develop our own language. We had aspirations that were completely infeasible, but we wanted to create our own language. And as part of the research you ought to do before embarking on a large project like that, we sort of looked at what was out there already. And I stumbled across this website from EPFL. Mm-hmm. And it was my business partner who was the brains behind it. So I said to him, have a look at this. This sounds like...
How did you stumble? How do you stumble upon something like epfl.ch?
I Googled, I think Google was around then. Yeah.
Okay.
2004,
Yeah.
And I found this language.
Okay.
I can't remember.
What did you Google for? Like interesting programming languages?
I must have searched for functional.
Functional.
And presumably object-oriented. I can't remember. Mm-hmm. Maybe it was just programming languages, and I went through a list of 50 pages worth of all the languages out there, mm-hmm. and somewhere there was Scala. Okay. I'm sure it wasn't on the first page, because it was only like 3 or 4 months after it was first announced.
Interesting.
But we tried it out. We compared it to a language that was around at the time called Nice.
Nice. I heard about it.
I've no idea what happened to Nice, but I remember it. We did some tests, and the choice was between Nice and Scala. Okay. And we went with Scala. And
so Scala was not nice.
Scala was not nice. It wasn't nasty most of the time, but we were then building the business plan. Remember, mm-hmm. this is two guys fresh out of university without any real world experience. Mm-hmm. Our plans were to sort of develop a language or some technology that interested us, funding that through some consultancy work. Mm-hmm. Now, as a startup without any experience, what we ended up doing was spending all our time working for no money on a few web projects.
Sounds like that's San Francisco startups.
Maybe, except there was no investment involved. Mm-hmm. This is England.
Right. Not very common thing here either.
Right, yeah. So we were building websites in Scala. We ended up having the first, what could be called the first commercial piece of software written in Scala. And I mean, the experience working with it back then, this was Scala 1.3. Mm-hmm. It was very pleasant most of the time. And then occasionally we'd stumble across some bug that absolutely threw everything. The compiler would fail to compile, it would crash for no reason. I mean, it wasn't like we suddenly started using some new broken feature. Mm-hmm. It was like we would be doing exactly the same thing we'd been doing for the first 80% of the project, and then one line would cause it to crash. Mm-hmm. So there were a few occasions like that were incredibly frustrating.
So it's hard to even imagine, right? Like the life before the Big Bang. What was there in 1.3, and what most common things we use now were missing?
So The thing that I use most now that was missing then was implicit values.
Okay.
Implicit conversions existed.
Okay.
You could automatically convert from one type to another if you put a value.
So that was there from the beginning.
That was there from the very beginning. Yeah. I'm trying to remember if higher-kinded types were there in some form. I think they were there in a limited form. Let me see. It's interesting some of the syntax changes that were different. Like self-types were there, except they had a different syntax. So you'd put a colon after the class constructor and then the type, the self-type, which I quite liked as syntax. And then later on that changed to the requires keyword. Requires was a keyword for a while. And then we got the current syntax, which I always thought looks too much like a lambda when it's just not a lambda. So I'm not a big fan of that. But
how about the collections?
Collections, well, they were far worse than they are now. I mean, I know the collections get a lot of criticism from certain quarters.
What about the API? Was they like the function names and methods, the whole idea of this?
The method names were, generally speaking, the same as they are now, except they were implemented only on certain types of collection, certain types of thing like so. You might find that list has a sliding method, but actually vector didn't exist, but sequence possibly didn't or something. I can't remember.
Did it feel intuitive? Because one thing which struck me when I started doing Scala is how intuitive the collection methods are. And I think personally that one of the reasons of adoption of Scala and also Spark, I think really benefits from this.
That is one of the best things about the collections library. The consistency, or at least the attempts at consistency. People will find places where they're not consistent.
And that was there in the early days too.
There were aspirations to have it consistent, but there were many more cases where things weren't consistent, mainly, but I think by virtue of the implementation being less type class based.
Okay.
And well, in fact, less inheritance based. So yeah, certain things were sporadically available on certain collections. Just it wasn't consistent.
So how did you kind of, I would say, crystallize the Scala? Because you were in one of the initial seeds of the Scala community, right? So how did you get in touch with the PFL, and where did you see community grow from there? Right.
So the first couple of years, myself and Jamie Webb, my business partner, I had no sort of face-to-face communication with anyone from EPFL. I remember Jamie, who was more active than me on the mailing list back then, had a meeting with Martin when he happened to be over in the UK, and they chatted about some stuff. Okay. And we had occasional meetups in London. There were a few of us. So the early London Scala user groups meetings.
Did they call them user groups? Did they call them meetups?
It was called no, it was a user group.
User group.
I think didn't the word meetup sort of evolve from Meetup the company?
I assume so.
It was called a user group anyway.
Right.
And we'd meet in a pub, and there would be about 10 of us at most, and there'd be a guy there who said, I'm using Java. I'd really love to use Scala.
You didn't project any code on screens?
No.
Yeah. There were no iPads either, right?
No, iPads didn't exist. So many things didn't exist back then.
All right, so you couldn't, but the laptops are there, so you could show some code to people.
Laptops were bigger and heavier.
Right.
I think it was rare we actually took our laptops out and looked at code. I think we were mainly just chatting about things we could and couldn't do, and all our favourite bugs.
So you were actually kind of industry users, right? So EPFL is this academic organization, this mysterious place from which Scala emanated, and you guys took it and used it in industry.
Yeah, we were industry users, but none of our clients knew we were using Scala. So we had a few sales meetings where we said, yeah, we're using this really cool language, called Scala. And I'd say, called what? What is this?
So the objective was to build their sites.
To build their sites, to build the back end. Back-end stuff, and they'd never heard of Scala, obviously. And if they did then go and look on Google for information about Scala, the fact there was so little was a good sign to them that actually it wasn't a good long-term prospect. and that they would have had maintenance headaches. And they're completely right in that decision. So we just told them it was Java.
Mm-hmm.
So we said, we're building your software in Java. It runs on the JVM. It's Java.
Smart choice.
So that's what we said. And I think we were only really successful in sales when we didn't tell people it was Scala. And it wasn't later until about 2011, I think. So after Scala Solutions, which became TypeSafe, was founded, I think it was only then that Scala actually became a positive, rather than a big red flag, a big risk for anyone.
I think it still happens. We see echoes of this.
I mean, yeah, it's still
Some
happening.
companies using Clojure Scala,
Yes.
they like to have Java APIs, and they kind of like to...
Or they like to have PHP. I mean, if you're judging based on how widely it's used, people will make bad decisions.
So basically, I'm following the trajectory. So you are doing this in industry. You have occasional meetings with visitors from APFL, right? when do you see the momentum picking up? When do you see this really changing the trajectory?
Well, the big thing was Twitter.
Mm-hmm.
I think in the last 11 years, the one single thing which has made the biggest difference to Scala has been the adoption by Twitter and their success. And the fact they managed to reduce their downtime quite significantly at the same time as they were expanding very rapidly.
Mm-hmm. And that was about
2008, 2009?
2008, 2009. And
Yeah.
you were in Europe.
I was in Europe, yes.
So how did you see, I mean, we live in a bubble world here, right? Like we kind of know
well,
that...
I was in a bubble within Europe called Britain.
That's right. But the ripples from here are spreading slowly. Sometimes they reach Midwest in a few years, right, and the East Coast, and so.
Well, I was really pleased to see Joe Barnes from Alabama. So Scala has reached Alabama.
That's right, and it's been there for a long time.
Yeah.
But so I'm curious how the Twitter phenomenon reached UK, and like how did you see this Scala explosion affecting?
It wasn't so much that the average developer even knew that Twitter was running Scala. I think it was more a matter of the tech leaders whose job it is to be aware of what's going on in the industry became aware that Twitter had used this, that they'd taken a risk on this language,
right,
and had been successful with it.
Right.
And then maybe they should consider that as well.
Right.
So it was. I mean, certainly not all decision makers were aware of it, and certainly many, quite reasonably, I think, still back in 2008 saw it as a risk. But the fact Twitter had been successful with Scala, I think that was an enabler.
Right.
And it enabled the formation of TypeSafe.
Right. I didn't know it was called Scala Solutions.
It was called Scala Solutions. I did a couple of weeks of work for them. I did some consultancy back when they were setting up.
I'm so glad they called it TypeSafe. Scala Solutions sounds like a...
Well, it was actually, TypeSafe was formed from two companies. There was Scala Solutions and Scalable Solutions, which was Jonas Bonnet's company. And you'd have thought you could find a sort of a common name between Scala Solutions and Scalable Solutions.
I think it's subsumption.
But
right?
yes, but they went with TypeSafe. I think for the best.
Yes, absolutely. That was a great name. So, and did you stay with Scala all that time?
Yeah. So I haven't written any Java code since about 2004, maybe 2005. I wrote some.
So, were you ever tempted or kind of thinking over whether you should do something else? Some other language?
I think it's probably best described as blissful ignorance. I'm aware there's a language called Haskell.
Yes.
Another one called Idris.
Yes.
They sound interesting, but the free time I have doesn't really allow me.
And I think they're both made in the UK now.
Yes.
Yeah.
Yeah.
So they're local.
They are local. Yeah. I'm actually living in Cambridge in England at the moment, which is where there's a lot of research into.
Right. The
into
Microsoft research.
Microsoft research. Yes.
Yeah.
Also F# is quite big there.
But as we know from Scala days, Scala is a gateway drug to Haskell, and the Haskelator is the future, as we've seen.
Yes, I'm looking forward to that.
So this is very interesting. So, can you tell us a little bit about running business with Scala for all this year? So obviously, especially through early days, right? It's a non-trivial proposition to work in the industry in this new language, and probably the nature of the business evolved. Can you talk a little bit about that?
Well, the early days, we weren't successful. We wrote a lot of Scala code.
Mm-hmm.
We were. I mean, one thing that did draw us to Scala was the fact that we could use Java libraries from Scala.
Right.
And it was very convenient being able to take existing APIs and libraries off the shelf and use them within Scala. But I did find a huge amount of my time was spent writing wrappers around those libraries.
Mm-hmm.
And I guess you could even say that that's the sort of inkling of where Rapture came from.
Uh-huh.
It certainly taught me a bad lesson, I would say, that you should reinvent everything.
Mm-hmm.
And because Scala didn't have anything back then, there were no Scala libraries.
Mm-hmm.
It was always very tempting just to rebuild stuff, reinvent the wheel
Mm-hmm.
over and over again, but make it better.
Yes.
And I'm not advocating this as a solution to anything. I still find it harder today to pick up somebody else's library rather than just create my own.
Interesting.
And it's a flaw that's developed from having worked with the language from the very beginning.
I see now, because every programmer has this little set of code they drag along with them all the time, right?
Yes.
They develop their own methods and they have
Yes.
their own utilities. So I think it sounds like Rapture is your bag of tools, which you are taking with you along different projects.
So I can trace code in Rapture, maybe one or two methods back to 2005.
Mm-hmm.
Jamie Webb wrote those methods.
Mm-hmm.
The ones I'm thinking of: stream data synchronously from an input stream to an output stream or equivalent. That is the code that's lasted with a few updates. It's lasted over 10 years. Well, no, about 10 years, I would say.
What source control system did you use?
We used, from the very beginning, we used darks.
Okay, I
Do you know
remember
darks?
that. Yeah, it's a great system with a theory of patches.
The theory of patches, which didn't work for the first couple of versions of darks.
Mm-hmm. And cherry picking.
Or at least I was never sure whether the theory of patches was wrong or whether my mental model of the theory of patches was wrong. But we persevered. We had occasions where darks would get tied in knots.
Mm-hmm.
And it would be just left spinning for ages and ages and might ultimately complete the operation we asked it to do, and we might get our code back.
So you had Haskell code lovingly nurture this budding Scala source.
Yes.
Have you ever been tempted to look at this Haskell source of darks when it was buggy?
No. I mean, I don't read Haskell.
Yeah. Did you build it from source?
We would have done. I'll tell you why, because I've been using Gen 2 Linux for the last 10 years.
Right. So you actually has.
So I mean, I didn't type the commands except the standard installation on Gen 2. But yeah, it was built from source.
Interesting. So you still have this dark repository.
I probably have them somewhere. Yes.
Yeah, you should contribute to the Computer Science Museum, right? Because this is one of the longest existing repositories in Scala. You should make sure that it's preserved. At least it's all important to GitHub, right? And then it will be a matter of public record forever.
Yeah.
And future.
Well, I continued with darks until probably about 2011.
Mm-hmm. I used it around the same time, right? So I think the ascent of Git kind of switched everybody to Git.
Yes. Yeah. Darks 2.0 was a big improvement. That made it usable, really.
Yeah, because there's some SSH issues and.
Yeah, but we were early adopters with Darks again, and Darks didn't go anywhere really.
Right.
Scala did.
Right.
You win some, you lose some.
That's right. So can you kind of highlight, some kind of the most interesting things you've done with Scala during these years?
Right. Okay. The most interesting things I've done. Well, my talk at Scala Days I thought was very interesting. I was quite excited by that. So I've found a way to provide checked exceptions in Scala.
Mm-hmm.
I probably don't have long enough to talk about the details, but Java's had checked exceptions for ages, and it always seemed to me like this was a point where Java had better safety.
Mm-hmm.
I mean, at a cost of like horrible boilerplate code and busy work, coercing your exceptions into the right mold, but it did have this additional safety checking that Scala never had. And the reason Scala never had it was that you needed to be able to accurately track the exceptions that could be thrown. So if you map across, if you map a lambda across a collection, say,
Mm-hmm.
that lambda may throw it might throw, I don't know, what's an exception? Some exception.
Mm-hmm.
Exception.
Yeah.
But the map method, you can't write the signature in such a way that you can derive the exception type
Right.
dependent on the lambda.
Right.
It's not possible in Java. But I've found a way of doing it in Scala,
Mm-hmm.
which involves mixing together like 3 or 4 quite advanced features. But I've got working prototypes, so I'm confident that I'll get something working.
Interesting.
Yeah.
I think it will be really interesting to look at that.
I would hope that within a month or so I'll have something that people can actually use.
So you gave the Rapture talk at Scala by the Bay conference
Yes.
last year, which was the inaugural Scala by the Bay, and I think it was a great success because it was one-liners, each of them kind of self-contained, showing some of the beautiful syntax and ease of use. And I hope we get to do something today alongside, following you in the REPL. But I wonder, how do you came up with this idea, and how do you see people reacting to that, and how much adoption do you see happening around the world when you present this library?
So people do seem to like the one-liners talk, because I've got about 50 slides. Each one has 1 line or maybe 2 lines of code,
Mm-hmm.
and because I've designed Rapture to be as intuitive as possible, you can just read that line and know what it does.
Mm-hmm.
And I've managed to do it in most cases whilst remaining completely type safe, taking advantage of quite advanced features of Scala, at least at the library level,
Mm-hmm.
whilst not requiring that the people using the library need to understand them.
Mm-hmm.
So, for example, going back to my talk at Scala Days yesterday.
Mm-hmm.
Was it yesterday? Yeah, it was yesterday. Seems so long ago. So much has happened since. I introduced the concept of modes. Now, modes allow you to pick and choose how you want your exceptions to be handled.
Mm-hmm.
So, do you want to return an option? Do you want to return a try? Are you happy with just an exception being thrown? Maybe
Mm-hmm.
you want to return a feature and execute the code on a fork join pool.
Mm-hmm.
These are all possibilities with mode, and you just import the appropriate mode, and methods that have been written in the right way, which is basically anything in Rapture,
Mm-hmm.
will actually change their return type
Mm-hmm.
based on the fact the import is there. So this is a really complicated thing, or you need to understand a few complicated things to implement it.
Mm-hmm.
The implementation is simple, but the concepts are I would say quite advanced. But end users don't see any of that.
It's a lot I think it's a common feature in Scala, right? The
It's a common feature.
Implementation is simple once you understand what you're doing.
Yeah, and occasionally it leaks. Occasionally that abstraction leaks. But with modes, it's been holding up pretty well, and you don't see any of that underlying high-kinded types or implicit or dependent method types which are involved in the implementation. All you see is, well, my method return type has magically changed.
Mm-hmm.
And it was easy.
And not just this, so I think this is a theme in Rapture, right? Like by varying the imports, you can make very different behaviors. And I think this, so I noticed a pattern when you mentioned this,
Yes.
right? And I think this is very interesting. So I wonder actually if that sounds like a very good modular way to alter the behavior. So can it be, for instance, combined with the build system to produce different behaviors in different contexts, right? You can have something on staging, something in production. By varying the imports, you will change the behavior of the library and the underlying code.
So you'd have to, well, you'd make one change to the code where, yeah, definitely, yeah. So you can have method return types that are dependent on the import.
Mm-hmm.
That's how modes work.
Yep.
And you can do completely different things, run different code, dependent on the import. That's certainly something you could do. Whether you want to have that configuration as part of the source, or as a compiler flag, or as an environmental variable or something. I wouldn't recommend environment variables. I try to make the source code usually a specification for how the software will run. That's I think generally preferable.
Right. So you can drop
but
drop in a single source
choose,
file with different imports.
But I mean, there are issues with that. For example, you can't change that behavior at runtime. Then. So
right.
There are different approaches.
But I'm thinking about things like, typical use of a cake pattern would be to replace a real base with a mock, right? So it sounds like you can achieve a lot of similar things with Rapture by changing the imports.
Yeah, the imports do give you a lot of flexibility, and I've gone through using the cake pattern. I used that for years and years. I was reasonably successful with it, I think. I came up with a name. I decided one day that it was. I'd actually eaten a cake that day. And
I've not been aware of this. Maybe you can tell us more about it.
Yeah, well, there were a variety of messages on the mailing list, which I answered. To which my answer was, well, you need to use this pattern here, and it didn't have a name. And I thought, can we like find a better way of describing this? And one of my colleagues had his birthday that day, and we'd had a cake for him. So the cake was there on the table. I thought, well, it's kind of you're slicing. Every trait is a slice of that cake, and then you've got layers within the cake, which sort of represent stacked or nested traits. And the compiler neatly checks all these slices fit together perfectly, and it seemed to fit. People liked it, and
that's a great name. It has a lot of allusions, right? Let them eat cake, to have the cake and eat it too. Right?
Well, yeah, I'm not sure you can have your cake and eat it, but you can. It does introduce many problems if you're not careful.
And there are, of course, a lot of deep discussions, right? I think it's a very common thread in Scala forums. What are the, how the cake pattern works? What are the benefits? Should we use cake pattern? Sometimes there are revolutions against the cake pattern, right?
Yeah, I would say if you set out with the cake pattern in mind as your goal, you're probably approaching the problem in the wrong way. I think if you find you've written some code that ends up looking cake-like, maybe that's legitimate. But I don't know. I've gone off the cake pattern a little bit, not as much as most people. I think. I think Daniel Spiewak still believes it's a good thing.
What do you use instead?
We're sort of the last couple of people who are still sort of using it.
So what do you use nowadays instead of the cake pattern?
Type classes. I think. I mean to say that type classes are a drop-in replacement for cake is maybe misleading, but normally if I need to do something that's not sort of obvious in sort of the Java subset of syntax that Scala has, I would reach for implicits and type classes.
Okay. So I think there is an endless amount of things we could discuss, right? And probably I'll definitely follow up next time we have you. But I'll probably close with your given one of the person's most experience, right? And I will compare it with the first 50 years of computing. When ACM celebrated the first 50 years of computing, and I was at Penn at the time where ENIAC was built, so this was one of the celebration sites. They made it 100 years of computing celebration because they celebrated the next 50 years in the first, right? So you've seen first 10 years of Scala. We're gonna probably meet here again and talk about 20 years of Scala.
In 2024, 2025.
That's right. So what do you want this next 10 years to be? What do you think they're gonna be? Where would you like it to go?
Oh, more of the same.
More of the same.
Yeah,
Sounds great.
That's it.
Sounds great to me. All right.
Cool.
Here's to more of the same.
Thank you. Thanks,
Thanks,
Alexy.
thanks, John.